Thank you for coming to this talk. My name is Jacek Bukowski. I'm from Global Logic. We have a booth here, so please, you are all invited to come and talk with my colleagues. And we have a spy tank to win, so just take a part of it with it. Okay. Today I will talk about cloud-native applications using Spring Cloud Netflix. What is it? It's a joint forces, as I call it, of Netflix and Spring. Spring brings some kind of simplicity of doing mostly complicated things, and Netflix brings its own, maybe probably not full, but brings its own infrastructure for the cloud applications, microservices, and so on. Let's see what we can get from it. Let's start from the very short, a little bit theoretical introduction. I don't want to talk too much about that, but just give you some background why Spring Cloud, where the idea comes from. Let's start from the definition of the cloud. I took it from the book Migrating to Cloud-Native Application Architectures. I will refer to this book later also. This definition, any computing environment in which computing, networking, and storage resources can be provisioned and released elastically in an on-demand self-service manner. What does it basically mean? That the cloud is the environment where you can, depending on your need, yourself add new capabilities. You need new hosts, you need new virtual servers, virtual hosts, you need containers, whatever the cloud provides you. You need more storage, more new database, you need a bigger bandwidth. Everything you just click and add, it's there. You pay probably for it, of course, but it's there. That we will think of saying cloud or cloud computing. Now, if you want to go to the cloud and develop the cloud applications, what you should think about. There are different service models, for example. Software as a service, platform as a service, infrastructure as a service, mobile backend as a service. Actually, when you go to Wikipedia and try to find all those AAS stuff, there are plenty of them, so actually it ends with everything as a service, and with a very nice acronym, just S. Cloud provider. What cloud providers should we choose? Let's go to Amazon Web Services or Cloud Foundry, any other. There are just 4 of them. There are maybe 10 more, the big one, and the hundreds probably you can find everywhere. Smaller, more specialized maybe, and so on. Maybe other, let's look at the other side. Let's maybe start from the technology stack. Let's choose a language. Well, for us it's obvious, right? Java. Almost obvious, because maybe a few years ago it was Java, now it's a little bit more. But still, at least for us, let's stay with JVM languages. So maybe let's choose a persistence layer. We want relational database, any? Or maybe let's be modern and take NoSQL database. Should we start from that? Actually, my recommendation is don't bother about those things. Those are the details, but maybe not necessary for you as the developer or the architect or whoever you are, but the more technical guys. Let's start from building everything to be prepared for the cloud, and then you can use anything you want, or almost anything you want. That's the book I took the definition of the cloud from. It's available for free. You can download it from Pivotal site. Just to you need to register there. This book is about 60 pages, as far as I remember. Not too big, but I really recommend to read to understand what really means developing a cloud applications. Actually, behind the word, there's a lecture about the microservices and the changes in the organizational changes you need to provide. So that's also in this book. So Okay, I will just refer to few things from this book. What they consider, what they think of as a cloud-native application. It's just a style of development. It's a set of patterns, architecture decisions that you should follow in order to be ready to deploy your applications in the cloud. There are a few characteristic things about them. First is 12-factor applications. Those is a collection of patterns for these cloud-native applications. Originally, that was created by the Heroku. You can see it is this 12factor.net page. And there are 12 aspects, 12 patterns they mentions. I don't want to follow each of them. You can read it later. But it's about, for example, dependencies, that your application cannot, should not put any assumptions on the environment you deploy on. So basically, it's not like a web application that you have a container application server and then you deploy and so on. You have no assumption about what's there. It's also, for example, about configuration, that you have one single code base. And if you need multiple instances, and sure you are in the cloud, you will have multiple instances, then just put everything which differs to the external configuration, and so on and so on. There are 12 factors of that. Next characteristic is the microservices. So if you want cloud-native applications, you need to divide your applications into a set of well-specialized services and deploy them separately. So basically microservices, everyone nowadays knows what is it. Next is self-service agile infrastructure. Actually, it's everything we already said about in the cloud definition. It's the infrastructure that is self-serviced, it's very flexible. Next one is API-based collaboration. API-based collaboration is about how two microservices are talking to each other. They can talk only through the published and versioned API. What does it mean? It means, for example, that you cannot have a storage shared between two services. It's not like the one service will store something in a database and another one will read it. They cannot collaborate this way, only through API. And the last one is very interesting, anti-fragility. Very strange word. Fragility is a term mentioning that the more stress you put on your system, the weaker it is, the worse it works. And anti-fragility is actually the opposite. The more stress you put in a system, it makes the system better. Sounds strange. When I heard it first time, it was impossible. I thought impossible. But actually, then I read an example from Netflix. What they have a special component that in the production environment artificially put some errors in a production environment, and that let them find the weak points in the whole system. It's actually very similar to the human immune system. It's getting stronger and stronger if you're exposed to pathogens, and it's getting weaker and weaker if you are completely quarantined. Yeah, you live in a clean environment. So that should work in that way. Okay, let's now quickly look to Netflix. This part of this two, we have Spring Cloud Netflix. So let's start from Netflix very quickly. Everybody knows probably Netflix. It's available in Poland since few months, and since few weeks probably, as far as I remember, it's available in Polish and you can pay in Polish currency. Why we are all the time talking about Netflix whenever we talk about the cloud applications, whenever we talk about the microservices? Those are the facts why, actually. First of all, they moved to this architecture many years before this term was even created. So they started in 2009 and microservices appeared in 2012, 3 years later. They are responsible for 30% of the internet traffic nowadays. More than 500 microservices, 2 billion calls to Edge gateway. So that's why, and 800 different client devices. That's why we all the time talk about the Netflix because actually they showed that this architecture can work and can handle this kind of the load and complicated stuff. Netflix is also contributed to the open source. They released many of their components. I don't know how many. What does it mean, much? They say much. Is it majority or not? I don't know, to be honest. But there are a few different areas. As you see, big data, built-in delivery, and so on and so on. And in each of the area, there are at least few services, tools, libraries, and so on. We are interested in these common runtime services and libraries. We'll talk about this later. That's the list of the components they have open sourced for that. We will see a couple of them later on, how they are integrated with Spring. So now let's go to the Spring Cloud. What is the Spring Cloud? Actually, the Spring Cloud is the idea of using this whole patterns and good practices defined in the cloud native application styles. They created this Spring Cloud in order to actually force you, or at least encourage, to follow all those good practices and patterns. It contains some common features that each component that is deployed in the cloud would probably need or should use. You can see like the distributed configuration, like load balancing, like fault tolerance, these kind of things. How it is done, how it fits to the whole ecosystem of Spring. So at the very bottom, we of course have Spring Framework, the core. On top of this, there is a Spring Boot. I think most of you probably know Spring Boot. And the Spring Cloud is on top of Spring Boot. In core, there are just two libraries, Spring Cloud Context and Spring Cloud Commons. Spring Cloud Context is an extension to the Spring Context, and Spring Cloud Commons is all those common abstractions Spring Cloud provides. Common abstractions does not contain any implementations of them, because implementations comes with another components. So we have two implementations right now. One is Spring Cloud Netflix and another Spring Cloud Console at the moment. And on top of the context, the Spring Cloud config, so this distributed configuration is done. There are plenty of other stuff. Components that integrate you with with some cloud providers, the component that ensures some distributed eventing, others. We are interested in that part here. We will talk a little bit more. Very briefly, let's go through this. What is this context extensions? Actually, just a new context. It's a parent for the main application context. What it is responsible out of the box is basically responsible for getting the external properties. So you have a very nice precedence of the properties. So the configurations like this, some default, then you have your own boot application YAML, so the stuff you normally configure, and then on top of this, with the higher precedence, you have the config server. So everything you put in a config server will win. On top of this extension for the context, we have the Spring Cloud config, two sides, server side and client side. What's the server responsible for? The server is responsible for exposing the configuration resources, and the configuration resources are, like in Spring, JSON file or YAML file or Java properties files through HTTP, and that's it. The client side will connect to the server and actually will behave much the same like it's reading the local application YAML family with those different files for different profiles. Just it will come from the remote server. Very interesting thing is the Git backend, because you can use a Git as a repository for your configuration, and config server will take it out from that. So the server provides this kind of resources here. Out of the box, everything is mapped like this. So the application will ask for the application, which is configured like the application name. The profile will be the active profile. The label will be by default master. You can override this with those properties. Yeah, and this label is very interesting because it lets you actually version your configuration. And if this is Git backend, then label is straightforward. Okay, now the second part, the second core library for the Spring Cloud, those common abstractions. So we have the abstraction for the service delivery, for the load balancing, client-side load balancing, and for the circuit breakers. And now we are here. We are in Spring Cloud Netflix, which are the implementation of those abstractions. So what we have here, what is taken from these Netflix components which are open source. So as a discovery, Eureka server from Netflix. As a circuit breaker, Hystrix. As client-side load balancing, Ribbon. Okay, we have a declarative REST client Feign, we'll see in a moment. Also, the last one is this, this is Archaeus, if I read it correctly. This is used for each Netflix component to configure its batch based on Apache Commons configuration. But actually, we don't need to bother about this. Spring translates its configuration and uses Archaeus to configure those all other components. So it's there, but we don't know it's there actually. And the Zul is also very important because one of the usage of Zul will be the API gateway. So you can provide the routing to the different services using Zul. Eureka, discovery client. How Spring Cloud make it easy to run and easy to use. On the server side, just put this annotation and your Eureka server is up and running with some defaults. But you can use a configuration to override those defaults. On the client side also, just put one annotation and you have a client. It connects, it has some default local hosts and a default port where it looks for the Eureka server. Very interesting fact is that Eureka server itself is a client, so it always looks for its peer. You need to add extra configuration in order to say, hey, Eureka server, just run in a standalone mode. It's a cloud, so you shouldn't probably do that. I did it for the demo on my laptop. Very interesting thing is those virtual URLs. So you can refer to the services by the name of a service instead of the host. And those are the clients. You can use directly the Eureka client API, of course, to get this. But also you have a REST template, which is aware of Eureka. So just use it, pass this virtual URL, and endpoint will be found in Eureka. Let's go next, Hystrix. I'm not sure if everyone knows what is a circuit breaking pattern, so let me briefly explain that, because it's really crucial for the fault tolerance. The thing is, you are calling some external resource, some external service, and you have a timeout. Then call it again, you have a timeout. Call again, you have a timeout. So probably there's no need to call it anymore. The service is down, so maybe I can try in 5 minutes. Maybe it's up again. That's why the circuit breaker? Because it opens the circuit, like in your home, the electrical circuits. It's opened the circuit, and now we have this short trip error. It's immediately reported, and you can provide some fallbacks. If you can provide a fallback, and then your system can work with some defaults. But there is no waiting for checking the timeout. And sometime later, there will be a retry to reconnect. And maybe the circuit will be closed again. So the Hystrix is the implementation. Usage is again very Spring way, just an annotation on the method you want to protect, and optionally point the method which should be used as a default. That's it. Additionally, it provides you with some metrics, which is really useful. There's an endpoint, provides you a metrics, and there is also a dashboard, the web application, you can review it. And the most interesting is the last one. If you deploy the turbine, it will gather and combine streams from different microservices to present you the view over the whole system, not just a single service, how it behaves. Load balancer, client-side load balancer. You can, of course, use this Ribbon API directly, but just in a second we'll see a Feign Client. It uses it out of the box. And the client-side load balancing is on the client side you have a list of servers, and it just chooses one of these. And what is nice, if Eureka is there and the application is a Eureka client, then you need, of course, populate this list. This list of the servers will be taken from the Eureka, the registered services. And now the Feign Client, very interesting, the declarative web client. All you actually need to do to connect to another service is just define the interface and annotate it. You can use a Feign annotation, you can use JAX RS annotations or Spring MVC annotations. It's almost like you were writing the endpoint, but it's another way. The client will be generated based on that. And out of the box, it uses Eureka. So if I have a name article service, it means it will pick up this service from the Eureka. Ribbon for load balancing on the client side, and the Hystrix. This call will be automatically protected by the circuit breaker. Okay, now that's all about talking. Now I want to show you that in action to give you some feel how that works, how easy it can be. What I will show is two microservices. One news service responsible for serving just top news. It's kind of the front-end service, the client will call it. Then we have an article service, which is backend storage for the articles. Each news is an article, so each news will be, the content of the news will be taken from the article service. We have also the infrastructure, which is the configuration server, backed by the Git repository. Sorry for this blinking. And we have a Eureka as the registry service. So what will happen when we run everything, each of the components, so two microservices plus the config server, they will register to Eureka. The config server will take the configuration from the Git repository. There will be just a YAML file. And the news service will pick up that configuration. What we then do, we will call this news service, just give me the top news. This news service should check in the Eureka where is the article service, call the article service to get the content. Some additional things, we want this call to be load balanced. Of course, on my laptop there will be just a once instance, but I want the load balancing to be there in the circuit breaker. And we will do it using 12 classes. Okay, let's try to see. Okay, just let me duplicate so I can also see the same what you see. No, it's wrong. Okay. Okay, I have a very simple project. We have the top level. It's a Maven structure, so we have a top level microservices and 4 components in it. So first of all, let's look at the registry servers of our Eureka. POM, some configuration. If you are familiar with Spring Boot, that is straightforward for you. In a configuration, all I need is a port where I need my Eureka is running, and the rest is because I want this standalone mode here. So don't look for the peer. And as I promised, one class. That's it, the main Spring Boot application class, annotated with that. So let's run it. Starting as a regular Spring Boot application. And, okay. I will try to not touch my laptop too much. Okay, it's up and running. Możemy coś z tym zrobić? Okay, let's see it. It's there. Not anymore. Okay, there are no registration. Here in the middle should be some registrations. It's empty, of course, at the moment. Then let me run the configuration server. Again, just a single class. We want to have it, to be it as a Eureka client, so it will register to Eureka. And it will be a config server. In the Git repository, we'll have just a single file, a YAML file for the new service configuration called newsservice.yaml. Okay, let it run. Let's refresh it and wait until config server is there, it's registered. And the config server serves, as I promised, some resources. So it serves this, but we can serve it like this. Let's say I want to have a YAML file, or I want to have Java properties file. Yeah. Okay, then let's run first of our service, this backend service, articles service. Okay. Article service is registered. And before it will stop working at all, let me run immediately the second service and let make at least one call. So in the meantime, let's call some article with ID 1. It's there. The content is, of course, random. I don't have any database. It's just generated. And news service is there. So let me call it 5 top news. It's there. The content is taken from the article service. And let's look that in the code, how it works. So here our news service. The main application class is also very simple. We just need to be it a Eureka client, and we want a Feign client, this declarative web services client. And as I already showed you, we just need an interface to write. It's just an interface. We put some annotations this time from Spring MVC. Yeah. And how we call it? We just inject that in the constructor of the controller. We just inject this Feign client, plus we are injecting the configuration, and this time this configuration will be taken from the config server. And I'm just calling it. That's it. This call has this circle breaker out of the box, has a client-side load balancing. If I have multiple instances of article servers, it will pick one of these from the Eureka server. Yeah. That's about it. I will just show you the one more thing for the configuration to prove that this is taken from there. So the default one is the 10 top news to be taken. The one from the config in the Git repository is 5, and when we called, the 5 was provided. Okay, that's it what I prepared. Short demo showing the cloud native application in Spring Cloud Netflix. Are there any questions?
What would happen when you stopped a backend service?
Okay, I'm stopping the article service, right? Error. Timeout. You see the last line. Get article timed out. Try again. You see it takes a while. It timed out. Timeout. 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 After a few tries, hopefully. Oh, you see how fast is it? Now the circuit is open.
So if you used Hystrix, then
Hystrix, yes.
Then you could provide some default content.
I can, yes. If I provide some default content, I would, as a client, I would even be aware of that something is broken, probably. It has a consequence, however. If I start now the article servers, it takes a while until this new server will stop responding again, until this circuit will be closed. But that's a consequence. Any other question? We have still 3 minutes, so despite of the technical problems. Yes? Just wait for the microphone.
How fast the change on the configuration server will be visible to the client?
That's not so easy question, because by default, the application will not be notified about the change in the configuration. That's how the default configuration works. You can change it. You can configure that each service is pulling for the changes, and then you say pull every 1 minute as you wish, right? But actually, it's not recommended. This is why the default is to turn it off, because you have this another component, which is the Spring Cloud event, or Spring Cloud event bus. Oh, yeah, I think event bus is the name. Because actually, in a cloud environment, doesn't make sense each of a single service to query all the time the config service asking, is my configuration changed? The much more sense makes to create an event, and then the application will be notified about the change. But you need some additional configuration. By default, like right now, I would need to restart the application to pick the changes. Yeah.
Proszę poczekać chwileczkę.
Could you please explain to me why did we get white label error page and you set timeout? Perhaps I don't understand the default Hystrix mechanism, but could you explain it?
I did not provide any fallback. So I don't have any default to serve in case the remote service is not responding, right? That's why I get the error, of course, because I cannot call this. The value is that I don't need to wait for the timeout. So imagine that you call this service 100 times a second. The resources will be very soon exhausted. Even if you are using async calls, it doesn't make sense that each of the request waits, I don't know, 10 seconds until it timeouts. After a few failures, the circuit is opened, which means I fail immediately.
So it's the response from Hystrix, not from our server.
Yes, this is the response from Hystrix because the circuit is opened.
Okay,
Yes.
thank you.
Dziękujemy za prelekcję. Zapraszam Państwa na 10-minutową przerwę.
Thank you.